So for lecture 2, we're going to begin with chapter 3 on cardiorespiratory exercise training. So this chapter looks at the basic exercise program design that improves several components of our health-related components of fitness, but more specifically, we'll be focusing on cardiorespiratory or cardiovascular fitness in this chapter. Now, even though we're focusing on it in this chapter, we shouldn't just concentrate on cardiovascular fitness and exclude other components of fitness training when we're working with a client or team. If our goal is to improve health and movement, then it's recommended that we train people not just in cardiovascular fitness, but also cardiovascular endurance, muscular strength and endurance, flexibility, and our neuromotor training as well. So if you remember back to our different components of fitness, we looked at this in lecture 1. On the left, you can see the health-related components of fitness. And if we improve our cardiovascular endurance, it helps to reduce the risk of cardiovascular disease. The stronger and more endurance your muscles have, the better you are to handle our everyday stressors such as carrying groceries or walking up and down stairs. On the right hand side was our performance or skill related components of fitness. And if you remember, we argued that both coordination and balance should or could also be considered health related components of fitness in terms of helping people recover from a fall if it's starting to happen, or preventing them from happening in the first place. So we're looking at cardiorespiratory or aerobic exercise. Aerobic endurance activities increase your heart rate and breathing rate. So that's kind of our definition of aerobic exercise. And so there's a wide range of activities. Usually it involves large muscle groups, repetitive or cyclic activities. So we're doing the same movements over and over again. And this is a good starting point for people, cardiorespiratory or aerobic activities, because it does require relatively low power output compared to our heavy resistance or strength training or sprinting activities, for example. So it's pretty safe for beginners to start with, especially if they're untrained. And then even with the low power outputs, we can see health benefits relatively quickly, especially for those that are untrained or have been sedentary. When we look at prescribing our cardiorespiratory or aerobic exercise, we use the fitness formula acronym, and F is for frequently, so that's for how often we exercise. I is for intensity, or how hard we exercise. T is for the time, or how long we exercise for. And the second T is for type, or which activities. So our cardiorespiratory or aerobic exercise typically is done for a long duration at a low to moderate intensity, but sometimes it can be higher intensity or vigorous in nature. So we're going to look at each of these different components of the fitness formula from frequency, intensity, time, and type as we go through our chapter 3. So we'll begin looking at the fitness formula, starting with frequency. And right from the text, it indicates that we want people exercising at a moderate intensity 5 days a week if they're doing more vigorous or intense physical activity, than 3 days per week with 48 hours of rest in between. Now, if your athlete's or client is a beginner, then they might need to start out with just the 3 days per week as well, with 48 hours of rest in between, even if it's moderate exercise. And then over time, we're going to increase the frequency and even increase the intensity, but one of those at a time, not both at the same time. So the question is, how do we define moderate and vigorous? And this is going to depend on the individual. What is moderate for one person is going to be quite intense for another person, especially if they are just starting out with their training. So if we go back to our principles of training, what happens if the intensity of the training is too low? And the answer is that it violates the overload principle, and therefore the body does not adapt. So we won't see supercompensation happening, and therefore fitness will not increase. So if we look back to our graph showing the overload principle from last lecture, we train, so we decrease the capacity of the body, and then with a period of rest, we recover, and the body increases its capacity, and that's where supercompensation occurs. So if we're not training at an intensity that decreases the capacity of the organism, we're not going to see that supercompensation occur. Overload did not occur, so supercompensation does not occur, and again, fitness will not increase over time. Next, we're going to look at the intensity of the exercise, and this is our most important factor when we determine the training effect. So think about our beginners, the untrained individuals. They've been sedentary for a long period of time. For them, walking at the beginning may be enough to achieve some health benefits and improve cardiovascular function. But for most people, and even those untrained individuals, after a short period of time, that walking is not going to be challenging enough. It's not going to overload their system, and we won't increase our fitness. And if you remember our study from last lecture on our non-responders, the low intensity group had the largest percentage of non-responders, whereas the high intensity group had 0 non-responders at 24 weeks. And intensity and frequency, or the volume of our training, tend to complement one another in a program. So how do we monitor intensity with our clients? And there's a number of different ways that we can monitor intensity, several that utilize heart rates, and the first two that we talk about here, percentage of maximal heart rate and the heart rate reserve, or Carbonen formula. You're going to be utilizing heart rate to measure intensity. And then our last 4 do not require us to use heart rate, although percentage of VO2 max, we'll talk about how there's a linear relationship between VO2 max and heart rate. And our METs, we don't commonly use METs with clients or athletes. Rating perceived exertion is a bit more common, and then the talk test method. Now, we commonly advise people to exercise at a certain intensity via their heart rate, but the problem with that is most people don't know what their true max heart rate is. If we really wanted to know, we'd need to exercise them to their absolute extreme and then immediately measure their heart rate at that time. So we exercise them until they're just at the point of complete physical exhaustion. We take their heart rate, and then that's what their max heart rate is. But obviously this would not be safe to do for beginners or anybody with an underlying health issue. So the solution to this problem is that we use age prediction equations. And we're going to look at several of these different formulas. The first one we'll talk about is percentage of maximal heart rate. Again, most people don't know what their max heart rate is. They haven't exercised to their absolute maximum intensity and taken their heart rate at that moment. And so our most common age prediction equation would be our 220 minus our age. But there's a lot of room for error there. The standard error of estimate is around 11 beats per minute with our 220 minus age. So your max heart rate might actually be 11 beats per minute higher or lower than what your age prediction maximum is. CSEP, which is the Canadian Society for Exercise Physiology, then prescribes that individuals exercise at about 60 to 90% of what their age predicted max heart rate is. And in order to achieve any cardiovascular fitness improvements, you want to hold that range for approximately 20 minutes. Now, as I mentioned, our age predicted max heart rate typically has been 220 minus age. So they'll give the example for a 22-year-old, age predicted max heart rate would be 198 beats per minute. And so if we're exercising at 60% of that range, then their lower range would be 119 beats per minute. If they're exercising at 90% of their age predicted max heart rate, then they'd be wanting to get their heart rate up to around 178 beats per minute. So their target heart rate range, 119 to 178 beats per minute. And if we're measuring heart rate for 10 seconds, it should be between 20 to 30 beats in that 10-second range. So as early as Thursday, we're going to be taking our 10 seconds count after our 1 mile walk or jog around the track. And the reason we take it for 10 seconds immediately when we stop exercise is because if we counted for the full minute, one, people might miss some or forget what they're doing. But two, over the course of that minute, your body is recovering, so your heart rate is slowly recovering, and we want to get that heart rate immediately after you finish exercise. So we typically take it for the 10 seconds right after you start. Now, more recently, CSEP has changed to using an equation of 208 minus 0.7 times your age. So we're going to show the different calculations on the next slide here. So under the old equation of 220 minus age, I am 45 years old, which means my age predicted maximum heart rate would be 175 beats per minute. And if we use that 60 to 90% guideline of where I want to exercise in between, my range would be 105 beats per minute to 157.5 beats per minute. So to achieve cardiovascular fitness benefits, I'd want to exercise within that heart rate range for at least 20 minutes per time. Again, that's more so for beginners. Our new CSEP equation is 208 minus 0.7 times 45. Again, my age. So it equals 208. Remember bed mass, we got to do the multiplication before we do the minusing. 208 minus 31.5, which equals 176.5. So not too far off from my age predicted maximum using the old equation. And then if we take my new age predicted maximum of 176.5 and apply that 60 to 90%, so times 0.6 equals 105, 105.9, and 176.5 times 0.9, which gives me 158.5. So my range using the new CSEP formula, it's pretty close. It's only about 1 beat per minute higher compared to the old equation. Next, we'll look at the heart rate reserve method, or Carbonin formula. And as we're going through this, get out your calculators and practice on your own as well. The heart rate reserve method considers a person's resting heart rate, and it's considered more accurate. Generally, the lower the resting heart rate, the more fit a person is, and it more accurately reflects the percentage of your aerobic capacity at which you're working at. So when do we want to take our resting heart rate, well, first thing in the morning, just after waking while you're laying in bed, again, taking your heart rates for 10 seconds, multiplying that by 6, and that gives you your resting heart rate. So the equation is a little bit different. There is our max heart rate, our age predicted maximum, 220 for a 22-year-old, it'd be minus 22 equals 198 beats per minute. Now to calculate the heart rate reserve, we want to take the max heart rate minus the resting heart rate. So we'll assume our 22-year-old has a resting heart rate of 60 beats per minute. So their heart rate reserve is 138 beats per minute. To calculate our different ranges, our lower level and our upper level, we take our resting heart rates and add 50% of the heart rate reserve. So again, for a 22-year-old, their resting heart rate was 60 beats per minute. And we do 0.5 of their heart rate reserve, so the 138 beats per minute, which gives us a lower level of 129 beats per minute. For the upper level, we're taking our resting heart rate and adding 85% of the heart rate reserve, so 60 beats per minute, plus 0.85 of 138, and we get 177 beats per minute. So their target heart rate range 129 to 177 beats per minute. And for the 10-second counts, somewhere between 22 to 30 beats per minute. Now, we'll show again with me calculating the heart rate reserve method or Carbonin formula. So my age predicted max heart rate was 220 minus, sadly, 45 years equals 175. My resting heart rate equals 52 beats per minute. So my heart rate reserve takes my age predicted max heart rate of 175, and we subtract a resting heart rate of 52 beats per minute, and it gives my heart rate reserve of 123. Now, to calculate my lower level, we take the resting heart rate and add 50% of the heart rate reserve. So my resting heart rate was 52, and we add 0.5 of 123, which equals 52 plus 61.5, and so my lower level is 113.5 beats per minute. For the upper level, now it's 52 plus 85% of the heart rate reserve, so 52 plus 0.85 times 123, which equals 52 plus 104.55, which gives my upper level of 156.55. So my target heart rate range using the Carbonin formula or heart rate reserve method is 113.5 to 156.55. So that means my lower target heart rate is a bit higher than what it was calculated with the old or new CSEP formula. If you remember that one, I was around 105.9. So 105 to 105.9. So we're about 6 or 7 beats per minute higher for that lower range. So there's actually quite a few of different age predicted maximal heart rates formulas out there, and these have been created from research by different researchers: Fox et al., Galish et al., Gulati et al., Tanaka et al., Arena et al., Astrand et al., Ness et al., Fairbairn et al. So on this slide, we show 3 equations. The first equation is our most common age predicted maximal heart rate formula, the 220 minus our age. And this was first proposed by Fox et al. Back in 1971. The second line is the newer equation that CSEP has adopted, the Canadian Society for Exercise Physiologists, and that was based on research by Tanaka et al. And then our third equation is the Hunt formula by Ness et al. And in their study, they found that age was the predominant factor affecting our max heart rate. Physical activity, sex, male or female, VO2 max, BMI didn't greatly influence the max heart rate. And in their study, they found that the standard error of estimate was 10.8 beats per minute, so very close to that 11 beats per minute that I mentioned earlier. So the range that people exercise at can vary greatly. Here we're looking at the fitness formula, and remember our fitness formula, our frequency, how often, our intensity, how hard, and our MHR is our max heart rate. T is for time or how long, and the second T is for type or which activities we're doing. So this slide is showing how we adapt the fitness formula based on one's fitness level. So the fitter you are, the more frequently you can exercise and at a higher intensity and for longer. So low fitness level here, generally we're recommending 3 days per week with 48 hours of rest in between. Our lower range of our age predicted max heart rate, and typically for a lower amount of time. Somebody who's of average fitness, they can exercise a little bit more frequently, slightly higher intensity, and for a greater length of time. And then our high fitness, now we're getting our back-to-back training sessions, so maybe a couple of days of training, then a rest day, and another couple of days of training, so 5 or more days of training per week, higher percentage of our age predicted max heart rate, and for a longer period of time. So we talked before about our cyclic activities, so repetitive movements using large muscle groups. So other than the common examples here, you can probably think of some other examples that involve repetitive movements and use large muscle groups. Now, if you're swimming, your age predicted max heart rate is going to be a little bit different. And there's a few reasons for this. One is you're horizontal while you're swimming. Most people, I tend to end up going through the water a bit more vertically, which is why swimming is so physically exhausting for me. But commonly, you're horizontal, and also swimming is non-weight bearing. So because the demands are less energy demands, we don't generally get our heart rate as high. We don't have to pump blood against gravity, so the heart doesn't have to work as hard. When we're in water, when we're submerged in water, we lose body heat a lot more quicker, about 25 times faster than if we're in air. So we don't have to pump our blood to the surface of the skin to release heat, so that requires less energy. So the formula that they use for predicting your max heart rate for swimming is instead of 220 minus your age, they use 205 minus your age. Now this doesn't mean that swimming is not a good form of exercise. In fact, it's a very good form of cardiorespiratory exercise. Again, it's cyclic activity. It definitely uses large muscle groups. It's just we can't use the regular formulas for predicting our max heart rate that we use when running. Next, we're going to talk about our percentage of VO2 max. And our VO2 max is predicted either using formulas from field tests or directly measured in the lab. So some of the field tests are 1.5 mile run, our 1 mile walk or jog. We're going to be doing those in lab, so we'll be predicting your VO2 max based on those results. Another field test would be the beep test, where you're running 20 yards back and forth between targets, and you have to get to each end before the beep sounds. The beeps get closer together, so you're having to run faster and faster until you can no longer keep up, until you're physically exhausted. not fun, but a good way of measuring your VO2 max with field tests. Lab tests usually involves graded exercise, so the exercise gradually gets harder and harder. So one example would be the Wingate test, where you're on a stationary bike and you're biking and the resistance on the bike is gradually increased until you're physically exhausted. Or treadmill running, and over a period of time the speed increases and or the elevation increases again until you become exhausted. And for both of those, the Wingate and the treadmill, they're measuring oxygen consumption. So as you might guess, the lab assessments are more precise, but it also depends on what type of exercise you're doing. If you're a runner, but you have your VO2 max assessed using the Wingate bike test, while the results will be fairly accurate, it wouldn't be as accurate as if you had the treadmill running VO2 max test done. Now, running generates a higher VO2 max than biking because more muscles are involved with running, and therefore more oxygen needs to be delivered to the muscles and consumed. If we knew a person's VO2 max, we could prescribe aerobic exercise based on a percentage of their VO2 max. So, for example, a prescription might be telling somebody to go for a 30-minute run at 60% of their VO2 max. And this it's viable for research purposes, but it's not really applicable in everyday life, because unless you're going to be hooking your athletes up to lab measuring devices to measure their VO2 max while they exercise, you can't really directly measure their oxygen consumption every time they exercise. So what we rely on is the fact that there's a linear relationship between your heart rate and your VO2 max, at least when we exercise at a moderate intensity. So the higher the heart rate, the greater the oxygen your muscles will need and that your body must deliver. So we can therefore prescribe based on heart rate that if we're telling somebody to exercise at a higher heart rate, then it's going to be challenging their cardiorespiratory system at a greater intensity. Another method of measuring intensity is metabolic equivalent. And metabolic, or 1 MET, is the equivalent of energy expenditure at rest. So the amount of energy that is required just to breathe or consume oxygen. And this is the equivalent of 1 calorie burns per kilogram per body weight, 1 kilogram body weight per hour. But nobody really uses this in general practice. It doesn't typically make a lot of sense to the clients or athletes unless they've had a long history of working at various intensities and they've been told what the MET is for that intensity. They're not going to know the difference between, I'm exercising at 2 METs versus 4 METs versus 8 METs. So generally, when the MET scale is used, it's divided into 3 categories. So light exercise is anything that uses less than 3 METs. Moderate is between 3 to 6 METs. And vigorous is anything above 6 METs. More common subjective measurement method is RPE, or the rating of perceived exertion. So our problem with our age predicted heart rate ranges, again, is that there's many different formulas and they all provide slightly different results, and they each have their own standard error of estimate. So some people may be exercising towards their higher end of their age predicted max heart rate, but they find it's not challenging enough for them, or their formula for the age predicted max heart rate has them exercising at one intensity and they're way below that, and yet they still find it very challenging. So in common practice, some people may use the rating of perceived exertion or Borg scale. And what we do is we take heart rate and divide it by 10. So if your rating of perceived exertion is 9, it's approximately 9 beats or 90 beats per minute, which would be very light for exercise intensity. Again, it's a subjective measure, so it's going to be different for every person. But with training, people get quite good at relating or predicting their heart rate based on their rating of perceived exertion. So if they've been told, okay, your heart rate right now is 150 beats per minute, that should be a hard intensity for you. If they exercise at a higher intensity and they're told, okay, your heart rate is getting up to 170 beats per minute now, that's very hard for you. So over time, with practice, people get quite accurate at predicting their heart rate based on what they think their rating of perceived exertion is. Another method, also subjective, is the talk test. And it just mentions that if we're exercising at a certain intensity, we're going to start to have difficulty carrying on a conversation. So sustained aerobic exercise or aerobic effort, this is going on for a long period of time. So for moderate, you can say words, you can carry on conversation, but you can't sing. Not that I have ever sung while I am exercising, but that's our definition for moderate exercise intensity. When we get to vigorous, you can say a few words, but you definitely can't carry on a conversation without pausing for breaths. So again, this is a simple method, especially people starting out exercising, to determine the intensity of their efforts. And in this table, we're comparing our different ways of measuring exercise intensity that we talked about: our percentage of max heart rate, percentage of VO2 max, percentage of heart rate reserve, rating of perceived exertion, and then how that number compares to the classification intensity for rating a perceived exertion. Talked about before how there's that linear relationship between heart rate and VO2 max. So if somebody's working at a higher intensity, their heart rate is going to be higher. They're going to be utilizing a greater amount of oxygen delivered to their muscles, and therefore the VO2 max is going to be higher. This equation that's at the bottom, percentage max heart rate, 0.64 times VO2 max plus 37. This was developed by David Swain back in 1994, and it shows that linear relationship between heart rate and VO2 max. Most people are going to exercise between 50 to 90% of their max heart rate. Exercising above that, above 90%, is unsafe, especially for untrained beginners. And we look at the health benefits. The evidence shows that we want people exercising moderately to vigorously several times per week. But for our sedentary or untrained individuals, we can start them out with light, and that's going to improve their cardiovascular fitness. In terms of cardiovascular disease mortality, we can achieve benefits through moderate activity. We don't have to get up into that higher intensity. While people will continue to improve their aerobic capacity, if they're exercising at a higher intensity, that's looking at fitness, and that's different than health. So you don't have to get to that higher intensity to achieve those health benefits. But if you're strictly looking at fitness benefits, then if you want to continue to improve beyond moderate, then you're going to have to move up into the higher intensity exercises. We'll talk more about high intensity exercise and high intensity interval training, or HIIT training, when we get to chapter 18. For beginners that are just starting out cardiovascular fitness training, sometimes aerobic intervals is a good way to begin. So in this case, they're not training continuously. They will exercise at a moderate intensity for a period of time, and then decrease the intensity slightly. Their heart rate is still going to stay elevated, and then they bump back up to that moderate intensity again. So walk run programs for people that are starting out running, utilizes that principle. So they gradually over time decrease the amount of time that they spend walking in between the running periods until they're running continuously. Now, important to note that the heart rate predictions is only relevant to aerobic exercise. We can't accurately use heart rates predicted training for strength or for sprinting. And we've mentioned it many times before that if you've been sedentary, you should progress slowly. And when we're increasing our workload, frequency, intensity, duration, you can't do all of that at the same time. You can only increase one of those factors at a time. If you try to increase too many factors or increase one factor too quickly, you're going to risk injury. So we're going to pause here and we're going to resume the rest of chapter 3 in the next video.